Hello guys, how are you doing? I'm excited to have you guys once again. Yeah, I'm excited to teach you guys again. Your class is I must confess, a wonderful class when I took you in year 7. You guys did pretty well, and I'm here again to take you guys physics again in year 9. But I must advise you, give you one or two advice, which is which you need to take seriously now that you're in year 9. Remember, year 9 is a checkpoint class, so you need to be up and doing. Okay, you need to tighten up your seatbelt, and you need to have more confidence in what you're doing, and then you need to study more, especially past papers, past checkpoint papers. You need to get them and start practicing. Okay, don't forget what you did in year 7 and year 8. They are very important, and what you're going to do in year 9 also very important. All right, my name is Kelechi once again. Many of you are familiar with me, so I'm not new to you guys. Okay, now for today's lesson, we're going to be treating pressure. Okay, page 150 of your textbook. Are you there? Page 150 of this book. Okay, can you see the book by the right hand side of your screen? Complete Physics for Cambridge Secondary 1. Okay, if you have it, you can scan through page 150. You can just open page 150 and see what's there. Okay, all right, let's not waste time. Let's quickly start. Now, the topic is pressure. Many of you are not familiar with pressure. How many of you are familiar with pressure? You've heard of the word pressure. Don't put pressure on me. You're putting more pressure on us, something like that. But pressure in physics is actually a force or weight acting in a given area. Okay, a force or weight being exerted in a given area. Right? When you sit on your seat at home now, you are exerting a force on your seat. Okay, that surface where you're exerting a force, that particular force you're exerting on that area is what we call pressure. Okay, all right, without wasting time, we'll go to the PowerPoint. What we have, pressure, we said, is a force acting in a given area, right? In which case will the man feel the most pain in his thumb? We have two cases here. So which case do you think the man is going to feel pains in his thumb? We have case A and case B. That's an office pain. Okay, so I guess it's A, right? Now you can see the pin on his thumb, but there you can see that the cap on the thumb. The pin on the thumb has a small area, okay, being exerted. A small area, no, it's exerting a force on a small area on the thumb, but that cap is exerting a force on a larger area, right? Okay, now the earth mover is very heavy. It has a weight of about 1,000,000 Newton, which is equals about 15,000 people standing. But it doesn't sink on the muddy ground. Why do you think it doesn't sink? But a single person, sometimes when you stand in the muddy ground, you find out that your leg is sinking. You're not as heavy as an earth mover, but you sink. Why? But the earth mover doesn't sink. Do you have any explanation for that? Okay, because the weight of the mover is being spread over a larger area. You can see the tires here, right? You can see the tires. So the weight is being spread over a larger area. It's using a big, broad wheel, right? and tyres, right? Now, how do we calculate pressure? If pressure is a force or weight that is exerted in a given area, how can we calculate it? So we can calculate it using this formula. Pressure, force, per unit area. This slash here means per or over. So pressure is the force per unit area. It's calculated using this formula. Pressure, force, over area. You know, it's a force actually that is exerted in a given area. Okay, so if you use much force and exert it in a small area, guess what the pressure will be? If this is big and this is small, of course the pressure here is going to be big, right? But if this force here is big and the area here is also big, the pressure here is going to be small. Okay, so the force you exert on small surface exerts more pressure. Remember that pressure is just a force that is being exerted on a given area. Now let's try something out. Can you take the cap off your you take your pencil or your biro, okay, the pointed area, exert a force on your thumb. Is it painful? Good. Now take the other side, the cleaning side, and exert the same kind of force on your thumb. What do you feel? Less painful, right? You can see that the sharp area is more painful, that is, it has more pressure, exerts more pressure than the big area, right? Good. So you can put this formula in a triangle. When you put the formula on a triangle, you're going to have this F at the top, P times A below, because if you cross multiply this, you can see that pressure will multiply area, isn't it? So F, the one the numerator here will always be at the top. Okay, this ones can be cross multiplied will be below. Are we good? All right, that's fine. So pressure, since pressure is force over area, the unit of pressure should be the unit of force over the unit of area. Can you guess the unit of force? Newton, right? How about the unit of area? Yeah, some of you are saying meter square, centimeter square, millimeter square. That's fine. Okay, but the standard unit is meter square. Okay, so 1 Newton per meter square is the same thing as a Pascal. If you don't want to use Newton per meter square, you can use Pascal, okay, as a unit of pressure. Are we good? Okay, so pressure can also be measured in Newton per millimeter square, Newton per centimeter square, and so on. It's up to you, the one you want to use, or depending on the situation. Okay, so we can all calculate pressure, right? It's easy to calculate. Now look at the question on your screen. We have this question. A force of 100 Newton is spread over an area of 2 meters square. A big force on a small area. Can you guess how the pressure is going to be? Okay, 100 over 2, 50 Newton. Wow, a very large pressure because the area is so small. But let's look at this force here. 2 Newton, a small force, and a larger area, 4 centimeters square spread. What will be the pressure? 20 over 4, a small pressure. Okay, so can we say that when the area is increased, the pressure tends to reduce? But when the area is small, you're exerting a force, so much force on a very small area, you get high pressure, right? Good. Now the other one is below. My screen is a little bit cutting it off. Yeah, in this second question, we have a weight of a footballer is 800 Newton and the area of his feet is 200 centimeters square. How much pressure is exerted by the footballer by his 2 feet? You can see the formula. We're using the formula force over area, so we're going to put 800 over 200. Sorry, the other one is not showing, but you can work it out roughly on your paper. 800 over 200 is going to give you 4 Newton per centimeter square. Notice that I'm using centimeter square, or I said centimeter square now because the unit here is centimeter square. Okay. Okay, the previous one we did here, it should be centimeter square, 4 centimeters square. So 20 over 4 centimeters square, which is the area, will give us 5 Newton per centimeter square. Now, in this case, we have, how about if we have the total area of a stud? Instead of using his feet, he decided to use wear this kind of thing here, a boot with studs. So, and the total area of 1, 2, 3, 4, 5, 6 stud times 2, which is about 12 studs, is 20 centimeters square. What will be the pressure? So all we need to do is 800 divided by 20 centimeters square, and then it will give us our answer. Okay, are we good? All right, large and small pressure. Pressure is exerted whenever a force is applied over an area. Okay, now let's decide the force diagram, this one or this one. Where are we going to have more pressure? Of course, this. The man is exerting the same force because he's using his hand, right? Because he's exerting a force here on this table with just one of the fingers, but here he's exerting a force with his hand with all of his fingers here. You can see the area here is bigger. Area where he's exerting the force is bigger, but area where he's exerting the force here is small. So the pressure here will be more. If the same force is applied in each picture, which arm exerts the highest pressure on the board? We've decided, right? High and low pressure. High and low pressure. Of course, we've decided the arm applies a force to the board via a fingertip. The force acts over a small area and so produces a high pressure. And this is the opposite. The same force is now acting over a large area, and then we have a low pressure. Okay, this side we have a low pressure. Sorry, the screen there is cutting some of it. I guess this is high and low pressure. Okay, now large pressure, still on the same case. Which of these shoes do you think is best to work with on a muddy field? This or this? This or this? Good. Yeah, it's good to work with this because it's flat, right? It's not pecky. It's not pointy. Cannot sink because it's going to exert a lower pressure because it has more wider surface, isn't it? Compared to this. This one has smaller surface here. So it's difficult to work with this on a muddy surface, isn't it? Yeah, we've made our choice already. So let's move to the next one. Why off-road vehicles have large tires and tracks? Can you guess why? Yeah, we know the reason why. We don't want to exert the smallest pressure, right, on the ground. So you want to exert a small pressure on the ground, you use something with big surface. So you can guess why these vehicles have big tires. They move on muddy areas, on marshy areas, in the forest, so many other areas, right? So because of that, their tires need to be wide, so they can exert a small pressure while they move. Okay, in this way they will not be able to sink. So they have a big tire so that they can exert a small pressure. Okay, now let's have an activity, a quick one, before we go to this. A quick activity you have. Write on the screen, write on the chat box, which will exert more pressure, the tip of a ruler or the base of the ruler. What I mean is the flat side or the pecky side. Which one will exert more pressure? Okay, if you cannot use ruler, use some other thing. Okay, your choice. Good. Now, why do you think my feet are wide? So that they don't sink on deserts, right? So that they exert more pressure on deserts and they don't sink, isn't it? Now, why are snowshoes used for walking in really deep snows? So that they don't sink, right? So that you don't get to sink on snows, right? It exerts a small pressure because the surface is wide. Are we good? Which will be more painful? I'll leave you to decide. Which will be more painful? The one with white surface being exerted on the ground, or this one? A heely shoe. So which one will be more painful for you? I'll leave you to decide that one. Now, why are ice skate blades sharp? Why are they sharp? Can you decide? Yeah, we need to cut through the ice. When you skate, you need to cut through the ice, so you need high pressure there, right? So that you can slide smoothly to cut through the ice, isn't it? So when you use flat surface, you can't cut through the ice because you're going to exert small pressure on the ice. Why are that sharp or pointed? So that they can pierce and hold on that surface, isn't it? If you use a flat one, what will happen? Nothing will happen, right? And the final question is, why does a sharp knife cut better than a blunt knife? Okay, guys, in case you don't understand the first question I asked you, you can use this. I want you guys to tell me this. Write the answer of this one on the chat box on Google Classroom. Why does a sharp knife cut better than a blunt knife? I want to really know if you understand what we mean by pressure, or what we mean by high and low pressure, where we have high pressure, where we have low pressure. Okay, remember, if there's area where you're exerting the force is small, you're going to have high pressure, and if the area where you're exerting the force is big, you're going to have small pressure. Are we good with that? That's nice. Okay, guys, in the next 10 minutes, I want you guys to go back to Google Classroom, and I have an assignment for you guys. But before you do that, you can forward your question to my WhatsApp. You don't have my WhatsApp, I'm going to text my number on the group WhatsApp group chat, so that you can see my number and ask me directly. Forward all your questions directly to me, to my mail chat box. Okay, whatever question you have, you can call me. You can feel free to call me anytime. Feel free to chat me up. It's all for the best, isn't it? Okay, guys, I wish you well. We'll see you in the next class. But before then, I'm going to go to Google Classroom and check out the homework I will give you. Okay, it's a short question type that you need to type the answers. Okay, are we good? All right, have a nice and wonderful day. Once again, I'm Kelechi, your physics teacher. Thank you.